So this is the angles guide coming out for the 7th grade quiz. Um, all it is, or sorry, this is the 7th grade angles quiz coming up for the 7th grade, obviously. And this is going to be dealing with different types of geometry usually and scale factors. So the first bit is about geometry, the second bit's about scale factor, and the last bit's a little bit more about geometry, specifically classification. So the first part deals with figuring out missing variables in angle formations. So if we look at the first one here, we have two angles, 50 and 4x, and we see that there's a big angle here that's 90 degrees. This little box right here tells us it's 90 degrees. And I want to know what's the value of x here. Well, it doesn't tell me explicitly, but I know that if I take 50 and I add it to 4x, I get 90 degrees because these are both smaller parts of this big angle here. So that's what I would set up as an equation. 50 degrees plus 4x is equal to 90 degrees. I know that based on the geometry of it. 50 and 4x together would make one big 90-degree angle. So I just solve for that equation. Subtract 50, subtract 50. You get 4x is equal to 40. Then you divide by 4, and you get x is equal to 10. And there's your answer. So again, you have to use the geometry of the picture to help you out. And usually the angles are either going to add to get some target number, in this case 90, or they're going to be like a number 2. So in number 2, these angles don't add together, but they do make this sort of X shape. So you have 3x plus 5, you have 65 degrees here. They kind of make this sort of X formation. And what that tells you is that they are vertical angles. So vertical angles are angles that share a vertex and are directly across from each other, or basically like this. So these would be vertical angles, and so would these. These would also be vertical angles. So both sides of the X are vertical angles essentially. And vertical angles don't add to a number, but they are equal to each other. So that means that 3x plus 5 is equal to its counterpart, 65. So I can use that fact to, again, set up an equation and solve. So subtract 5 from both sides. You get 3x is equal to 60. Divide by 3, and you get x is equal to 20. And there's your answer. So they're either going to be equal to each other, or they're going to add to equal some target number. Now, in the next ones, they're going to add to equal some target number, but the target number is going to be based on what shape you have. So in this case, it's a triangle, and we should know that in a triangle, that target number is going to be 180. So all the angles inside a triangle should add to 180. So 48 plus 87 plus 7x minus 4, because I take the entire angle, whoops, minus 4, is equal to 180. And these are plus signs, not t's. Sorry about that. So I'm going to use this as an equation, set it up, and solve. So the first thing I want to do is combine all my like terms. So in this case, 48, 87, and minus 4. Those are all non-variable terms, so I can put them all together in here. So 48 plus 87 minus 4 gives me a grand total of 131. Bring down my positive 7x, my equals, and my 180. Now there's nothing more for me to combine, so now I start solving. So I'm going to subtract 131 from both sides to get my 7x more alone. I get 49 here. And then I divide by 7 on both sides, and I get x equals 7. So again, they're going to add to some target number in a shape. Look at what that target number is, set up your equation, and solve. Now for 4, this is a quadrilateral. It's a 4-sided object. So I don't know what the target number is off the top of my head, but I can figure it out using this formula. 180 times n minus 2. This formula will tell you what the target number is for the inside angles for any shape, as long as you know the number of sides. And that's what this n is here. The n is the number of sides in the shape. So if I want to know what should these all add up to be in a 4-sided figure, if I have 4 sides, I want to add up all their angles. What should that get me? I'm going to use this formula and say 180 times 4, because 4 sides, minus 2. Well, 4 minus 2 is 2. So 180 times 2 would give me 360. So this is my target number. All these angles should add up to 360. So I'm going to write that as an equation. 80 plus 75 plus 105 plus x is equal to 360. So just like before, I'm going to combine my like terms. So that's 80 plus 75 plus 105 because I can do all that because those are all non-variable numbers. So this is 260 plus x equals 360. It's an x. So I'm going to subtract 260 from both sides, and I get x is equal to a flat even 100. So in this case, again, you're going to add them all up and then solve your equation just like you did number 3. It's just that your target number has changed. Instead of being 180, it's now going to be 360. And again, if it was a 5-sided or a 6-sided or a 10-sided object, you could do the exact same thing. All you would have to do is just replace n with a different number to make it work. So if you had a 6-sided object, n would be 6. You'd do this formula here. You'd get a different target number, and then you'd still add up add up everything you know and solve the equation to find your missing variable. But this formula is what holds the key there. On the next page deals with a little bit of scale. So scale deals a lot with proportions and ratios. So in this case, it says using a scale of 1 centimeter to 1.5, so I'm going to write that down as a fraction. 1 centimeter for every 1.5 feet. How long would it take, or how long would a model airplane be if the actual airplane is 30 feet long? Well, we want to know how many centimeters, so x centimeters for 30 feet. X centimeters for 30 feet. I want to keep these ratios equal, keep these proportions equal, because that's how model planes work and model anything works, is you have one ratio that's set and you want to keep that throughout the entire stuff. Well, if I use 1 centimeter for every 1.5 feet, how many centimeters do I use for 30 feet? Well, I can just cross multiply, among other things, but cross multiplication is the most direct here. So x times 1.5 is 1.5x, 1 times 30 is 30. You divide by 1.5, divide by 1.5 to get rid of the 1.5, obviously, and solve for x, and you get x is 20. So you need 20 centimeters to make that model plane look good. So when you're solving this type of problem, again, the goal is to get the base fraction down, get the scale factor fraction down, which is this one right here. Get that fraction you know down, and then use it to compare and complete the other fractions that you don't know. So there's always going to be at least one fraction you do know, and that's the ones you're going to use to help you compare. Now, number 6 is a little bit different. Number 6 says that you have a statue that's this high and this wide, and a sculptor's making a model that's going to be that high and that wide. What was the scale factor that he used? So basically, he's asking, how did I get from these numbers to these numbers? What did I do to go from 18 and 6 to 12 and 4? What did I multiply or divide by? Well, you can do that by simply multiplying and dividing yourself. So for example, if I want to go, how did I go from 18 to 12? What did I do to get from 18 to 12? Well, you just simply take 12 divided by 18. And if you reduce this as a fraction, you divide both of them by, I think, 3. 12 divided by 3 is 4. 18 divided by 3 is 6. So you can divide them both by 2 now. So 4 divided by 2 is 2. 6 divided by 2 is 3. So the scale factor you used was 2/3. 2 feet on the model is 3 feet on the actual. So that's the scale factor you use, 2 to 3. For every 2 feet on the model, there's 3 feet on the actual, and vice versa. For every 3 feet on the actual, he used 2 feet on the model. You can write this any way you want, as long as you know which one's your model length and which one's your actual length. And I could do this with 6 and 4 as well. Obviously, you can see right here. If I did 6 and 4, I would have gotten this fraction right away, and I can go straight to 2 to 3 that way. So this is the scale factor that he uses. This is what he's multiplying or dividing by to go from 18 to 12. 18 times 2/3 would get you 12. That's how I knew to make it 12 feet high. Same thing for 6. 6 times 2/3 is 4. That's how he knew to make it 4 feet wide. So when they're asking for the scale factor, they want you to get the fraction. So take one piece from which your starting point is, in this case the statue, take one piece from there, take the corresponding piece from the model, and put them as a fraction and then reduce it. That's how you tell your scale factor, is you take one piece of the actual, one piece of the model, put it as a fraction, and then reduce. And as long as you make sure you label which one's your model and your actual, you should be okay. Number 7 is a lot like the first one. Two cities are 1,200 miles apart. How far apart would they be on a map if the map has a scale of 1 centimeter for every 320 miles. So again, 1 centimeter for every 320 miles, that's our scale factor. I want to know how many centimeters for 1200 miles. So once again, you cross multiply. X times 320 is 320x is equal to 1 times 1200, which is just 1200. And then you divide by 320. So again, very similar to the first one, except the exact same as the first one, just different wording. And this gives you 3.75, what would be centimeters. That's how far apart they would be on this map. So the first and the second one on this, sorry, the first and the last one on this page are pretty similar. The middle one with the scale factor is a little bit different. But again, they're all about setting up your fractions and ratios correctly. The last one goes back into geometry a little bit with a little bit of vocabulary. So we have possible triangle classifications here and possible quad classifications here. And we want to figure out which one best fits each sentence. So a triangle with one right angle and two equal sides is called a what? Well, one right angle means it's a right triangle, obviously. And two equal sides means it's isosceles. So I would call this a right isosceles triangle. Or you can say an isosceles right triangle, it really doesn't matter. But it says here use both angle and side, so you have to use them both. Right because it's a right angle, isosceles because it has two equal sides. What is this shape here? Well, we said we have two equal sides opposite each other, so it can't be a rhombus, a kite, or a trapezoid. It can't be any of these three because a rhombus has all equal sides. A kite does not have sides like this equal to each other. A kite does not have opposite sides equal, and a trapezoid doesn't either. So in this case, it has to be either a rectangle, parallelogram, or square. And because it has all sides equal, but there are no right angles, and because opposite sides are parallel, that means it's going to be a parallelogram. Because it does not have all right angles, but the opposite sides are congruent and are parallel, so it is a parallelogram. If it had right angles, then it'd be either a square or a rectangle. This one is a triangle, so we have to have two classifications again. It has three equal angles and three equal sides. So there's three equal angles, that means it's a equal angular triangle, but in order to be an equal angular triangle, it has to be acute. Because if the angles are all equal, they can't be bigger than 90. Otherwise, the triangle would be too big for itself. So it has to be acute because all the angles are equal. And then because all sides are equal, we call it an equilateral. Or equilateral, depending on how you want to say it. So equilateral, whoops, my bad. Equilateral simply means all sides are equal. And acute because all angles are equal, so you could call it equal angular as well, but we usually just call it acute because if it's an equal angular, it has to be an acute for a triangle. So you do have to know some of the definitions here. Remember, scalene is no sides equal, and equilateral is obviously all sides equal. A trapezoid, remember, is a triangle with the head cut off, so it looks something like this. A kite is kind of just the picture of what a normal kite would look like, or a stretched out diamond. And a rhombus is the trickiest one. A rhombus is a normal diamond, or put another way, a rhombus is a square without all right angles, essentially. Or a parallelogram with all sides equal. That sort of sense. But again, as long as you know the basic definitions of these, you should be okay. So that wraps up for this one. Hope you enjoyed the video. Have a good day.